So question number 4, I have this circuit that was given to me, shown in figure 28.21. And the question part A is to find the voltage across the 3 ohm resistor. So the voltage across this resistor here. Okay. In order to solve out these problems, first I need to figure out what the equivalent resistance is. So I need to simplify the circuit all the way down to 1 resistor. Okay, so that's our first goal. And then I will backtrack my way through all the problem to figure out what the voltages are and the currents are in each of the resistors. Or more specifically, the one in question, the 3 ohm. So our first step here is to look at this circuit and see what we can simplify. So the first thing that comes to my mind here is this one. See, I can remove this component, and that is a parallel set of resistors. So I can simplify that one first. There's no other ones in here that you can remove cleanly that will give you, like for instance, the 4 and the 3. You cannot remove those. Those are not in series with each other because if I remove this over here, it is still attached to the battery through this line. Okay. Likewise, the 2 and the 4, or the 2 and the 3 here are not in series. If I remove the part up here, I'm still attached in multiple places. Like I have to be able to make 2 simple cuts of the wire and remove that component to simplify it. So let's go ahead and do this one. So what I'm going to do is I redrew the circuit here, and I'm going to simplify this component, this parallel, into a single resistor. And then the rest of them I have left alone. So to simplify this, we look at what happens in parallel, and it is 1 over R equivalent is equal to 1 over the first resistance, which is 10, plus 1 over the second resistance. Well, 1 over 5 is the same as 2 over 10. So I've just made that quick simplification that 2 over 10 is the same as 1 over 5. This gives me a like denominator, so I can add these up. And this will give me a 3 out of 10. But 3 out of 10 is 1 over the R equivalent. So I need to flip that. And that's how I get the equivalent resistance here of 10 over 3. Okay. So here we have the circuit. Everything remained unchanged. The only thing we did is simplify just this one little part. And that got us at 10 over 3. So you want to do these in small, simple little pieces. Then I look at this circuit and I move on. I go, okay, where's the next thing I can simplify? Well, if I make a cut here and a cut here, I see that these are in series. Okay, and I can remove those and work out the equivalent resistance for these two. So that's what I've done. So I come down here and my 2 remains the same, my 3 remains the same, and I'm going to make these 2 into 1. Okay, so in series, they simply add together. Okay, in series they're going to add together. So I have 10 over 3 plus 4. So 4 is the same as 12 over 3. Okay, 12 divided by 3. So if I have 12 and 10, that'll give me 22 over 3. So by adding these two numbers up, I get 22 over 3. Or if you put it in your calculator, I think you'll get like 7.33 repeating, I think. So our next step, now that we have this circuit, is to keep going. So I see another set of parallel. If I take and I cut here, and I cut here, that's a parallel. So now I want to take my parallel and add them together. So just like I did up here. Okay, I take 1 over this resistance. 1 over this resistance would give me 3 over 22. This flips around, 3 over 22. Plus, I'm going to have 1 over this resistance, 1 over 3. Okay? 1 over 3. These two added up and then set to the negative first power or flipped will give you a resistance of 2.13. And that 2 has remained the same. So 2, and we got the 2.13 from here. Okay, so now we've just got 2 resistors. We're getting there. We just have to add these 2 up. Okay, these 2 need to be an equivalent resistance. They're in series, which means they'll just be added together. So that gives us an equivalent resistance of 4.13. So now we finally have the simplest circuit we can. 4.13, and this whole thing was originally tied to an 8-volt battery. So I've got an 8-volt battery. Now I have my V, I have a singular R. Now I can determine what the current is based on Ohm's law, V equals IR. The battery is supplying 8 volts, the current would be I, and the equivalent resistance for the entire circuit is 4.13, which means I'm going to have a current in this section of 1.94 amps. All right, we found our 3 things. Now we go back and we add those 3 things onto the circuits previously as we keep building and building. So I look at this circuit and this resistor and I say, what was this resistor made of? This resistor we made from series. In series, current remains the same through both. So this current here will be the same current that goes through both of these, 1.94. Okay, and this current likewise, 1.94. Now you can fill out all of these if you wish. I'm going to concentrate mainly on this resistor because this one involves my 3, which is where I'm trying to get to. Okay? So I have one more thing to solve. V is equal to IR. I don't have a V in here. Okay, so let me add a voltage. How do I find V? Well, V would be equal to I times R. So 1.94 times 2.13. If I can get my calculator to go correctly here. 1.94 times 2.13. This will give us a voltage of 4.13. Okay, in this resistor here. That's not my 3 ohm yet. I still got to go back more to get to my 3 ohm. So I look at what this resistor was made of. This resistor was made of these 2 parallels. Okay, these 2 that are in parallel. In parallel, the voltage remains the same. Okay, so if this is the resistance, my voltage there should be 4.13. Okay. So this gives me the voltage on that 3 ohm resistor. And it looks like probably when I did this originally, I did not shortcut the little leftovers here. I most likely kept it very, very long, or I kept it in fractional form. We could easily say that was 4.13. Okay, very, very close. I'll change that in your homework so it matches up with my solution. So the voltage on that 3 ohm is 4.13. Well, what is the current? Okay. Well, the current is, again, we're going to use Ohm's law. So I have 4.13 equals to I times R. Okay, which means I'll have 4.13 divided by those 3 ohms, and this gives me a current of 1.38. So likewise over here, I'll change this to 1.38 so that it matches up with my solution. 1.4 is very, very close to 1.38. Same with the 4.26 is very, very close to the 4.13. Just a rounding issue is all that we were seeing there. Okay, so there's your 2 solutions. You have the voltage is the same